Alright, we're going to derive the quadratic formula. The quadratic formula is a formula that allows you to find the roots of any quadratic equation. So a quadratic equation in general form looks like this: ax squared plus bx plus c equal to 0. And there's two steps we need to do at the beginning. We can do them in either order. I'm going to do this is my first step. I'll subtract c from both sides. And then what I'm going to do is complete the square on the left-hand side. And so to do that, I first have to divide both sides by a to get rid of that leading coefficient. So when I divide the middle term there by a, I get b over a x. And on the right-hand side, I get minus c over a. All right, now this is the completing the square step. I need to take half of this coefficient b over a, square it, and add it to both sides. So half of it is simply b over 2a. That's what's going to get squared and added to both sides. Now, when I add it to the right-hand side, I'm just going to put it in front, and we'll see why later. Okay, so this left-hand side is now a perfect square trinomial. And I can collapse it and just write it as x plus b over 2a, all squared. On the right-hand side, I can expand this. I have b squared all over 4a squared minus c over a. So if I want to combine these two terms on the right, I need to have a common denominator. And I can create a common denominator by multiplying by 4a over 4a. That creates a denominator of 4a squared, and the right-hand side now becomes b squared minus 4ac, all over 4a squared. Okay, so this is sort of the halfway point, if you like. So I'll scroll down a little bit. We now have to undo everything that's being done to x to get the roots of this equation. So the first thing is to take the square root of both sides. And that leaves us with x plus b over 2a on the left. On the right-hand side, you have to remember that you have both a positive and a negative square root. So we have plus or minus the square root of the numerator, b squared minus 4ac. The denominator, though, is a perfect square. When you take the square root of it, you get 2a. And then the only thing left is to bring this term over to the right-hand side. And again, I'm going to put it in front. So I have minus b over 2a plus or minus square root of b squared minus 4ac all over 2a. And the last thing is just simply to combine these two. Conveniently, they have a common denominator. So I end up with minus b plus or minus the square root of b squared minus 4ac all over 2a. And that is the quadratic formula. It will allow us to solve any quadratic equation regardless of whether it can be factored or not. If you use the quadratic formula and you get rational roots, that means you could have factored it in the first place. The radicand, this expression here, b squared minus 4ac, has a special name. It's called the discriminant, because it allows you to discriminate between certain types of solutions. If the radicand is positive, then we're going to get two different or distinct real roots. If the radicand is 0, we're going to get two identical real roots, essentially one root. And if the radicand is negative, we're not going to get any real roots at all. Additionally, if the radicand is a perfect square, then the roots are going to be rational, which means we could have factored it in the first place. And if the radicand is not, if the discriminant is not a perfect square, but it's positive, that means we're going to get two irrational roots.